ZK Nation, what is going on? Today, we are unpacking the Atlas upgrade to the ZK stack, a giant leap in performance that's making it more practical and compelling for teams from startups to enterprises to launch their own high-performance, low-cost ZK chain. If you want the full deep dive, check out the blog post on the ZK Sync Mirror account titled The Atlas Upgrade. And if you're really interested, see the live demo at projectatlas.zksync.dev to watch the system's unbelievable throughput in action. It truly is a sight to see. Today, I am your host, Dustin, and with me today is the one, the only, Mr. Anthony Rose. How are you doing, sir?
I'm doing well. Thank you for the exciting introduction.
Yeah.
How are you?
I'm doing fantastic. I'm excited to pick your brain about this upgrade, and really excited to see it go live into production. It's going to be a great day.
Yeah, me too. Big, huge day. A lot of work, and we can jump into it.
Awesome. Yeah, the hype around the Atlas upgrade is real. Internally, externally, I'm sure once the announcement hits the feeds, the Twitterverse is going to light up. And for anyone who hasn't read the blog post yet, and again, I encourage you to do so, let's set the tone for today. Can you give the audience that's watching this video kind of the ultimate TLDR? So, Anthony, if you had to describe the Atlas upgrade in one sentence, how would you put it?
Oh, it's a good question. For me, the Atlas upgrade in one sentence. So I would say exciting high-performance sequencer paired with a near real-time proof system, which unlocks an architecture that can support a blockchain network for the future.
Very well put. Maybe some semicolons in there, but I love it nonetheless. That's fantastic.
It's a big upgrade.
It's a big upgrade. That's exactly right. Now, one thing that's been very striking to me, and I got to ask, Atlas. This is the first time ZK Sync has actually named an upgrade. And this is kind of like a tech subculture of naming releases for software releases. To me, immediately kind of invokes this intuition of scale and strength. Why call this one Atlas? What's the story behind the name?
Yeah, for us, we've had names in the past. I think my favorite being Bujum. And I think we wanted to build on this, history with mythical creatures, let's call it, even if the history is short. But yeah, I think you've nailed it for Atlas. Like the next one being Atlas is really about the strength, the performance of the system. And it's the start of many more to come.
That's awesome. Yeah, I mean, I think this is an exciting upgrade, and the timing to name the upgrade, it just coincides with how big and important and meaningful this upgrade is. Of course, these systems evolve over time. It's an iterative process, just like any type of software. And we've gotten to this Atlas upgrade, but there's been systems that have come before it, Era VM and ZK Sync Era. What has been this kind of evolution of iteration that has led us to this big upgrade? And I'm curious, kind of in your holistic viewpoint of what exactly has this iteration looked like? Can you kind of provide some context, and maybe if you have any visualizations, that'd be fantastic.
Yeah, I would say for us, there's some background in the sense that you can think of ZK Sync as evolving in generations. From ZK Sync Lite, kind of much more like a prototype. Can we do this thing where we move some fraction of the activity off-chain and use ZK to prove it? Yes. Era then was the generalized version of that. Can you build a general purpose system with a proof system? And the answer, of course, again, was yes. For us now, we can see, and I genuinely believe we can see the architecture that will bring the global economy on chain. I think the work that we are doing now is in the direction of really putting that system in place, and like genuinely believe we're there. This system will and can do that. So I can kind of give you a picture of what it looks like as well. Okay, so for me, the interesting thing about the Atlas upgrade is that it very clearly positions sort of, I would say, the two core architectural components for the vision, as I see it, of the network, right? So I would say my assumption about the future is that if public blockchains are going to deliver on their promise, we're not going to see the world of one giant chain. We're going to see the world of, many chains. And in most cases, I would assume big teams connecting to, blockchain infrastructure, blockchain networks through infrastructure they control. Much like, enterprises today will have production environments, they'll be running Kubernetes clusters, databases, whatever. I think they'll be running, infrastructure that connects, provides services to their users, and then connects to the ecosystem at large. This, in my opinion, doesn't look like this, right? This is the sort of naive solution of lots of L2s, effectively, for the big reason that while Ethereum is an incredibly powerful, settlement layer, providing security, providing decentralization, doing interop or like exchanging messages on this sort of networked economy of blockchains through L1 just doesn't seem to work, right? Like in that world, basically every interop message is an L1 transaction. Okay, like this is like kind of the heart of the problem for me from a sort of architectural perspective, where we have this economy up here, things need to talk to each other. We want to use L1 for the things that it's good at, including, settlement and finality. How do we solve the coordination problem up here and build this networked economy? So this sort of steps towards, a simplified version of this architecture where we have a bunch of these chains. Each of these chains can be configured differently for what they want to do, right? So for example, I've just given them, okay, we have some fintech company, some enterprise use case, whatever else, different sizes, approximately representing kind of like different levels of scale on the system. We have private systems kind of indicated by this red box with the little privacy symbol in the corner. But, walking through this, what do we really have? We still have finality from Ethereum, all of the, properties of security and decentralization coming down here. Rather than the L2s each having to kind of coordinate their own state, we have this shared pool of liquidity on L1. So this pool of liquidity represents the assets, kind of L1 assets across the entire network. And then what we have is these chains that are able to use ZK to settle very quickly to prove to the rest of the world, to the rest of this sort of networked economy, that what they're doing is legitimate, that their system is transitioning correctly, even if the transactions on that system are private from the rest of the world. So for example, with this private blockchain, you can generate a proof that the state transition is correct. So everyone can see that you're obeying the rules of your chain without telling anyone what the transactions were. All of the user data can be private. So each of these chains produces a proof. They produce a proof for every block. The blocks can be aggregated here, and kind of the state of the entire network can be updated by this sort of coordination layer. Okay, so like, why is Atlas interesting? let's jump in. So the real reason Atlas is interesting is twofold, I would argue. Maybe three, but like two big components. One of them is the speed of the proof system, right? So Airbender is a generation ahead of the proof system that we've been using. And in part, its most compelling property is probably its performance, right? So you're able to generate a proof in 1 second for the blockchain that you're operating. So every single one of these chains can be in near real time verifying their correctness to the outside world. So this is incredibly powerful for a few reasons. One of which is because you get fast finality, right? So for you as a system, your state transitions are finalized very, very quickly. Within 1 second, you can have your state transition completed. You can produce your ZK proof, and then you can have your ZK proof verified on this gateway layer. So 1 second ZK finality is possible. And then because Gateway is settling very, very frequently to Ethereum, within minutes, you've got the full finality of Ethereum. So there are no, long periods where the L2 state is deviated from kind of the state that's finalized on L1. It lets you have this very fast finality system without, the costs would otherwise be involved of like processing a ZK proof every 1 second and verifying that on Ethereum. So very, very fast to generate, very, very cheap to verify, which means that you can have, proof costs that trend basically towards zero. So the cost of doing the transfer basically is the cost of doing the transfer. Doesn't really have a lot of overhead from the proving side. So very fast proofs is one really compelling property that comes with it, the Atlas upgrade. And this is in part due to the upgrade of the proof system that we're calling Airbender. This, coming back to our point about interop between these systems, is also incredibly powerful. So if these teams are to talk to each other, the question becomes like, how do you do that in a way that works? You could choose, for example, to implement the naive solution, which is basically to say, for every blockchain that I want to interact with, I will run a full node for that chain, so that I never have to worry about the state of the system. That, if they're telling me a transaction is coming in, I'm running a full node of their system. I know this transaction exists. This just obviously doesn't scale, right? So, for example, if I'm running my enterprise chain, maybe I've got 100, 200, however many, n100 partners that I interact with through my supply chain, through sales, through whatever it happens to be. There's obviously no way I'm running 100 full nodes through these partners. If I was to add a partner, I have to deploy a full node, spin it up, like just falls apart, obviously. You could use trusted third parties where somebody takes on the risk of that transaction in the sort of traditional implementation of a bridge. Again, doesn't scale very well, partly because for every new partner, you need bridge infrastructure deployed, contracts on both chains. For every transaction, you would only be able to trust it as much as you could trust that third party that's operating the transactions. So the beautiful thing about 1 second ZK finality is that you get this protocol level trustless interop, kind of anywhere to anywhere in the network, any asset to any destination chain, cross-function calls from system A to system B. And because it's being done with ZK, it's not like passing a message around. It's kind of like passing the message around locked in a safe, right? So that the message hasn't been tampered with. You have mechanisms to guarantee and verify that what is you're being told by another system, or what you are telling another system, is actually the true state of the world. How does this work? So we have this chain A. Let's say we want to be sending a message. Maybe we're moving some value from an account on chain 2 to account on chain 5 here. I get to say, I want to send my 100 USDC to this account. This can be the fact that I'm sending this, then within 1 second is included in a proof. The proof is verified on gateway, and this chain has access to that update in a way that it knows and can kind of trust that this ZK built safe has been passed to it without any malicious operation. So yeah, what it gives you is anywhere to anywhere. These links are not. These links are kind of at the protocol layer. Any chain to any chain, any message, value transfer, cross chain call. All of this can happen, basically, in real time. So users get a very, very good user experience, and it's all done without this extra step that introduces either latency or risk that typically we see for interop solutions more generally. Again, proof system needs to be fast and cheap to make this real, because basically you don't want the proof system to get in the way. You don't want it to add costs, and you don't want it to add latency. So, for both in the Atlas upgrade, we have Airbender. It's providing both, right? It's fast and it's cheap. And this interop layer can just be built into the protocol layer. And it's, you deploy a new ZK chain, you have access to the liquidity of the entire network on day one. So Airbender is a massive step forward. Very, very exciting. And, ZK, we're used to breakthroughs in ZK coming through all of the progress across the broader ecosystem, but it still continues to surprise me, even, after 4 years of working in it. So, okay, this is kind of like on the proof system side of Atlas. But there's the other dimension to it, which is, coming back to this example, if I am building one of these chains, I obviously care about a lot of the properties we've discussed. I care about finality. I care about access to, the liquidity of the entire network. I care about this ability to connect to other teams. But what I also care about is the performance of my own system. I'm building infrastructure. I'm going to deploy it as part of my production ecosystem. I care about its properties. I have things that I want to provide to my users. I care about the performance, the latency, and all of the rest of it. And with the Atlas upgrade, the other really compelling piece is that we rebuilt the sequencer. So the component in the system that takes transactions, processes them, and updates the state of the blockchain. This has kind of been implemented from scratch, designed for speed and designed for low latency on transaction inclusion. So what that means is your users are able to send transactions to the system you operate as a blockchain team, and they're able to have their transactions included extremely quickly. We're talking, hundreds of milliseconds, very low block times, very fast inclusion times, and very high throughput on your system. So what that means exactly, there's some more details in the blog post, but essentially we've run a bunch of demonstration exercises, and I've seen numbers between 15 up to some more contrived examples like 45 plus thousand TPS. And this is for the first version of the system. So we've designed it to be fast, we've designed it to have high throughput, but we haven't optimized it. So we're starting to see something that is really sufficient for enterprise scale. It's a highly reliable, highly secure system. And then when you fold in things like account abstraction and all of the other pieces that we've come to know and love on the user experience side, you can imagine actually having teams provide an integration with existing applications that they support that feel like that Web2 experience, but are able to process at the level of scale that can handle serious amount of load. I mean, 15,000 TPS it's a huge amount of volume, right? This is millions and millions of transactions a day. So this is live. This is a big rebuild for us on the sequencer side. Much more to come as this component matures, but obviously very exciting on the performance. There's another sort of more low-level change that accompanied this, which is that we effectively have changed, let's call it like the operating system of the chain. And without maybe getting too deep into the weeds, the most significant change here is effectively a change that adjusts what we prove. So with Airbender, you're able to prove this instruction set known as RISC-V, which we see many teams in the space, working with, improving. And the nice thing about this is you're able to take programs, written in Rust, written in C++, written in other languages, compile them, approve them. So what this means, kind of from the chain operator's perspective, and what it means for users of the ZK stack, is that you have more flexibility with the type of system that you're building. So, for Era, we have what we call the Era VM. So this EVM compatible execution environment. With this upgrade, you're now able to deploy the EVM natively. So you can just prove the EVM. You can prove a WASM environment. You can prove the Era VM. But it's really just another sort of step forward in the customization of the ZK stack. But very exciting, at least for us, to open up more options when it comes to the virtual machines that teams may want to be deploying for their ZK chain. So yeah, zooming out, we kind of, coming back to this picture of this like networked ecosystem of chains. This Atlas upgrade gives us two pieces, right? It gives us an improvements in node and then improvements between the nodes. So for me, it's like this is two important parts of the architecture both see progress.
So this is very compelling. How does that same 1 second ZK finality and high throughput change the game for things like cross-border settlement, FX, and even securities clearing? Like these are use cases that blockchain enthusiasts have been seeked after to bring on chain. This seems to really kind of open the door for those types of use cases.
Yeah, I mean, the very compelling part for me here is that at the protocol layer, everything is in place for you to basically just have, these financial rails active. So any chain is able to connect to any other chain in near real time with all of the guarantees that come from a ZK proof. No trusted assumptions, no like third party connecting you and taking on the risk and blah, blah, blah that you pay for. It's just at the protocol layer you can talk. And you can talk in a way where you don't have to re-execute anything. It's just a ZK proof that this thing is correct. So really, when it comes to the specific use cases, chains are still free to say, I want to add this, KYC or AML or whatever layer it is that they want to be able to do, or they want to interact with, systems A, B, and C for whatever use case they're solving. But the protocol layer is effectively a solved problem. So it's just coming down to the customization, like what do you want for your, business use case to support when it comes to, interacting with others in this networked economy.
And this is a huge unlock, like particularly for private chains. They can now safely interop with public liquidity without exposing any of that customer sensitive data. I mean, that is a huge unlock that opens the door for this level of customization based on whatever the whatever kind of niche product or market you want to try to capture.
Yeah, totally. I mean, think about it. If you wanted, for example, to build, some chain today to provide private transactions across all of your users, absolutely that could be done, right? If there's some enterprise Web2 company that wanted to enable payments on their platform, this system would let them do it. They can do it in a way where they're also able to access the deep public liquidity of the billions of dollars on Ethereum.
Interesting. You said payments. That is, one of the more kind of lucrative or very interesting use case that we often kind of compare against existing card networks. Are we getting close to the point where these on-chain payment systems that perhaps make use of ZK Stack can rival or even beat out these existing card networks?
This is a beautiful segue. So yes, so that maybe brings us to arguably maybe the most obvious in terms of its like external visibility component of the Atlas upgrade. So the second huge thing that I want to highlight is we rebuilt the transaction sequencer from scratch, and we designed it for high throughput and low latency inclusion of transactions. So, obviously we care about, if you're building a chain, you care about being, connected to deep public liquidity. You care about inheriting, security and decentralization guarantees. You care about all of the interactions you can have with the rest of the world. But you also care about your own system, and you care deeply about the architecture being correct, the security, reliability, the user experience you want to build on top of it. So with Atlas, this new sequencer is able to massively outperform anything we've done in the past. And we've done, load tests demonstrating different configurations of transaction, all the way from 15,000 TPS up to, tens of thousands of TPS for different use cases. So what you're able to do is, build the user experience that you want for your users using account abstraction, configure the system to have whatever gas token, DA layer, whatever it is that you're trying to, build for your application. But you can now process a level of throughput that is kind of in family for enterprise level loads, for payments, for whatever use case you're bringing on chain. So tens of thousands of TPS are available to your users without spikes in the fees, and all of this proved with extremely low cost through Airbender.
So Anthony, high throughput is available in other kind of architectures. It's certainly available in optimistic rollups. Like the ZK part is a point of emphasis in this architecture. Can you kind of speak more about its importance and why it matters for this kind of economy of chains?
Yeah, so as you said, high throughput alone is not enough, right? So for example, I don't think the future of on-chain finance is going to be some monster L1, right? Some super high throughput system. It just doesn't work to scale to the entire world. So what you need is very high throughput, low latency, high performant nodes for people to be able to build a system that makes sense to them. But to interact with the real world, to interact and participate in this on-chain economy, you need real-time ZK. Like, it lets you prove what you're doing is correct without revealing the state of the system. And you can actually see how this builds, the edges in this graph of which the nodes are different parties in the economy.
Okay, so with the Atlas upgrade, we get high throughput, 1 second proving, low fees, a multi VM that right out of the box is EVM equivalent at the bytecode level. What new application categories does this unlock?
There are, of course, many, for example, DeFi that requires fast finality, fast connectivity, access to liquidity. All of this is enabled by this architecture. ZK finality in 1 second and a high performance system gives you a massive and powerful platform for the next sort of generation of DeFi applications. But for me as well, thinking through things like the support for privacy, the support for the low latency Web2 like UX. This, I think, is how we're going to see sort of the next sort of step in growing the pie, in particular around things like TradFi. Right? We see RWAs, we see stablecoin, we see mainstream fintechs like Robinhood and Stripe moving into the blockchain world. This architecture is exactly what I would say these teams need. Very high performance system, very reliable, very cheap, but with that ZK guaranteed connectivity with the rest of the world.
It's interesting you mentioned Robinhood and Stripe, who kind of announced their intentions to build an L1. This kind of trend has kind of existed for a number of years, where it's largely been kind of a hit and miss for many teams, and mostly misses when we consider the failings of Libra and otherwise. If you could talk directly to these teams and try to kind of compel them to try the ZK stack for their own purposes, what exactly could we kind of attract them to take a look at ZK stack for their particular purpose?
For me, being in a position to decide what technology I think is going to emerge as dominant in the future, Ethereum is where the liquidity is. Ethereum is where the activity is. Ethereum is where there's a huge economy that also has the decentralization and security required to secure value at the level that we're talking. And then what do you want alongside that? You want your system to be high performance, well designed, secure. All of the properties that I would argue the ZK stack has been optimized for, I think are very well suited for anyone in that category, thinking about how they're going to kind of build their infrastructure and sort of access this growing on-chain economy.
We've seen kind of huge gains from fast proof systems, and 1 second proofs was kind of mythical 3-4 years ago. Are we at the point of kind of maxing out where we can get to with proof generation time? Is there a bottleneck, or what's the kind of the next? Do we need a more of a technical breakthrough in order to surpass this plateau?
I would say don't underestimate ZK. Even having been in the space for the last few years, I'm still surprised by the level of progress. Airbender surprised me. When I saw the performance when the team were building the system, I was genuinely surprised by how well it was able to perform. So when you see technology moving at the rate of 10x, let's say, improvements year on year, like, who's to say that this is the last one, right? Like, what we'll see next year, 2 years, 5 years from now, I expect to be an evolution of where we are today, substantially. That being said, 1 second proofs, proofs with like 4 zeros in front of them in terms of like the cost per transfer. Not to say there's diminishing returns in continuing to make improvements, but to go from like generating a proof in hours to generating a proof in a second is fundamentally different than like generating a proof in a second to 100 milliseconds, let's say. So these proof systems are staggeringly good, and they are, ready for prime time. So they'll get better, but they're ready today.
Yeah, not only the cost of them and the speed of them, but the hardware requirements are also dropping quite significantly, as mentioned in the blog post, which I'm sure everyone is excited about as well. Atlas gets us one step closer to kind of this vision of this economy on chain. What is the next big milestones for ZK Stack?
Yeah, great question. So lots in the pipeline. We are talking about interop between these systems with ZK Connect. We'll be kind of expanding the functionality of that a lot in the coming months. There's obvious progress that we're always going to continue to make on having the UX be better, the DevX be better, making the system more secure and more decentralized. So many things to come. This is an exciting day to celebrate progress, but we're already thinking about the next few upgrades.
That's awesome. And one question that I think is on everybody's mind is, when will we see Atlas in production in mainnet?
So I would say Atlas is basically production ready right now. We have the first systems already on testnet. We saw at Token 2049 the exciting announcement that the ADI chain to support this dirham-backed stablecoin for a lot of what's happening in the UAE. This is ready and being kind of deployed imminently. So multiple testnets are here. I'll let the teams talk about when they're ready for mainnets, but it's all right upon us.
That's fantastic. Yeah, one of the bread and butter of the ZK Stack network, and certainly with the ZK Stack, is the level of consciousness towards security and making sure these systems are ready to go live in production. If Vitalik were to kind of listen to this Q&A and play around with the Atlas upgrade, what emoji do you think he would tweet about it?
Does Vitalik tweet with emojis very often?
I don't think so, but this could be a first.
I wouldn't like to assume, but I do hope he takes a look at the system and, with EVM equivalents, with this level throughput on the system, with native EVM bytecode support and low latency proving. I hope he's a fan.
That's awesome. Well, thank you very much. That is our first look at the Atlas upgrade, a major milestone towards ZK Sync's vision of fast, secure, and seamlessly connected sovereign chains. A big thanks to Anthony for breaking down how 1 second block proofs, ultra low fees, and massive throughput are opening the doors to new apps, new players, and serious enterprise adoption. If you're a builder, this moment's for you. Explore the Atlas upgrade, see what it makes possible. If you're interested in spinning up your own ZK chain, come talk to us and start building today at zksync.io. Thank you very much.
Cool. Thank you, Dustin.